Hello, I'm Pandora Hope and the lead CI of Project 2.2, Enhancing Australia's Capacity to Manage Climate Variability and Climate Extremes in a Changing Climate. This project covers many sub-projects, and the Deputy CI is Christine, and we've put this together to try and give you just a flavour of some of the findings we've made throughout NESP 2.2. So what is the problem? Well, Australia is profoundly influenced by climate variability and climate extremes, and we know that these are happening on the background of anthropogenic climate change. But how much of these changes we're seeing is due to anthropogenic climate change, and how much is that due to just natural variability? And again, how are those natural variability drivers changing due to anthropogenic climate change? We really need clarity on this to see what's driving our climate now and into the future. So what did we do? We disentangled the extent to which humans have contributed to the severity of recent extreme events, and we enhanced the understanding of the climate variability that influences Australia, in particular El Niño and La Niña, the Indian Ocean Dipole and Southern Annular Mode, and how to objectively describe East Coast lows and other storms, and also describe the the influence of these on important impacts like drought, and then communicate those findings to next users and the government, and through NESP to businesses and managers of natural and managed environments. So this was the outcome of a workshop where we reviewed Australia's research into El Niño Southern Oscillation. And really the big point is that external climate driving climate change is influencing everything about our climate, including those interactions that are so important to driving the variability shown by ENSO. And so what are the impacts over Australia? On the right-hand side, we can see temperature anomalies in the shading. So you can see the pattern of El Niño in the bottom right, in the traditional or Eastern Pacific El Niño. And surprisingly, the anomalies over Australia are not very great. But when that anomaly in the Central Pacific shifts to the west, the impacts over Australia are actually much greater. So much warmer and drier in Central Pacific El Niño. And a PhD student recently published in a high-profile journal, Mandy Freund, that these Central Pacific El Niños are increasing in their frequency in recent decades. Other work has shown that we can now better identify Eastern Pacific El Niños and their variability in climate models, and we can now see a clear shift in ENSO variability in those same models. But there's other research going on to actually identify why this is going on. And we look forward to looking at this in CMIP 6. Coupled with this, El Niño-related rainfall variability might also increase. Now, the interaction with the Southern Annular Mode to our south really works to amplify or minimise the impacts from El Niño, particularly through spring, and that interaction might be weakening in the future. We also looked at the Indian Ocean variability and how that's represented in models. The positive phase of the Indian Ocean dipole brings drier conditions to rainfall. And there was some hypothesis that those extreme positive IODs might be increasing in the future. And this study revealed that perhaps that was actually underestimated. We were also the first group to use the Access CM2J, the coupled climate model developed by the Hub in Project 2.1 for climate experiments. And we clamped variability in the Southern Pacific, which is where we believe the decadal driving force of the tropical Pacific variability is coming from, with good results. And now other people can pick these results up. We also developed novel approaches to exploring the influence from climate change using a coupled dynamical forecast model, past and future. So these methods can be picked up by other researchers, but the results are giving us real insight into the ocean-atmosphere interactions and the processes that impact on Australia's climate. If we look to how Australia's rainfall is changing, these are graphs of Australia's winter rainfall. And we can see in the southwest there's been a shift that just seems to be outside of anything that variability due to El Nino or La Nina might throw at us. But on the east coast, that variability in the red dotted line due to El Nino is actually what's driving the rainfall decrease there in the future simulations under a high scenario. If we want to identify the impacts, it actually helps to be able to identify storms. And this is some work drawing on historical information right back to 1873 on the number of landfalling tropical cyclones that have major impacts. And there seems to be a decreasing trend in these, which aligns with some of the results on how many tropical cyclones we expect in future, where we expect fewer but perhaps more extreme tropical cyclones. East coast lows, like for El Ninos and ENSO, there was a synthesis of the knowledge on East coast lows, and we now have a go-to reference on these really important, impactful storms. And storm environments have also been explored across the broader region using novel mathematical methods that help us pinpoint the dynamics of those storms. So these are features that we can now use in the climate models objectively. Moving on to how we assessed the influence from climate change on extreme events, we used a variety of methods, and we also developed some new ones using the seasonal forecast model. And we analysed heat waves, extreme wet conditions, frost, marine heat waves, dry conditions, and fire weather. Generally, temperature extremes were easily attributable to climate change, but other variables were more challenging. And it's really quite exciting science to try and get at what's going on with extreme rainfall or drought, for instance. Getting even more extreme, we looked at mangrove dieback in late 2015 in the Gulf of Carpentaria, and how the climate variability and low sea levels driven by El Nino influence the trees themselves and what drives their health. The extreme attribution work was picked up in a number of places, including the State of the Climate in 2016, 2 conversation articles, and leading cross-chapter box in the IPCC's 6th Assessment Report. And we've also been responding to many queries from the Department of Environment and Energy. So what have we got as outputs? About 30 peer-reviewed research papers, and I'm sure there's more to come in the next month. Numerous conference presentations. Chai even appeared on Chinese TV. But importantly, we've developed new methods for understanding climate models, their biases and tools to really explore variability and change for Australia. We've also got the go-to references on ENSO and East Coast lows written under this project. It's pretty exciting stuff. So these findings are useful and relevant to decisions and planning activities for agriculture particularly, and infrastructure, but also risk planning. And this is really important as we go forward. So we've significantly increased the understanding of many aspects of climate variability and change, and increased the profile of some of the project's researchers, both nationally and internationally, to the point where they've been invited to write review articles in high-profile journals, and I've been invited to be on the IPCC, which has been a great experience too. So we've increased the reputation and we've increased our knowledge so we can be trusted advisors on the topics of tropical variability, drought, extremes attribution, both internationally and within the Department of Environment and Energy. So where to next? Project 5.2, Understanding Climate Variability and Change, Past, Present and Future. So we'll continue as we go through the next year and a half to further explore the dynamics and impacts of Australia's climate drivers and distinguish the influence of climate change and natural variability on extremes. But we'll start to synthesise some of the results, such as those on drought, and share them. We're introducing some other outputs on flash drought, and finally we'll synthesise the results that are coming out in the next 18 months, as well as some of the developments we've had over the last 3 years. Thank you very much, and if you have any further questions, please feel free to email me, but I might not respond. I'm on leave for the next month. And Christine Chung is stepping in, and please do feel free to contact her over the next month and both of us after that. Thank you very much.